What's up, everybody? Welcome back to a very special episode of Basic Chem 101 with Sihle. My name is Sihle, and today we are looking behind the reactions.
Let's go. This is how every child that wants to make it one day. Zimbo say class and presence of mind is elsewhere. Bringa usuzani afna uhle already aliswani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, heavy.
So you may be surprised that we've jumped from where we left off last week, but this is a special edition of this session. Actually, this one is offbeat. It is inspired by those people who didn't stay home but went to work so that some of us can be well and we stop the spread of the virus. So, and some of those people are people that I studied with, analytical chemists. Some of those people are your doctors. Some of those people are your nurses. There are people that are called essential services. So this episode specifically is dedicated to them because there is a bit of chemistry in finding the cure of this virus. So we'll be looking at how do we synthesize, let's say, a certain drug. But now to make this very short, we'll look at the synthesis, let's say ethanol, because ethanol is an alcohol, and in those sanitizers they say 60% of alcohol is needed. So we will take basics, not how to make ethanol, but basics on the reactions generally. So this is what we are looking at, and this is dedicated to the modern day heroes who go to work while we stay at home. Let's look at that. Okay, they say that the most important thing right now is a hand sanitizer, and a hand sanitizer is supposed to be at least 60% alcohol and then some ingredients for it to be effective. So let's say you look at, let's say your alcohol is ethanol. So this is your ethanol. Now, one other way of synthesizing your ethanol is when you have your alkene in the presence of an acid and water, then you get your ethanol. Now, what we are actually looking at today is the chemistry behind the synthesis of this compound, because if you remember when we started, we spoke of chemistry being able to manufacture life-saving drugs. Now, as you grow in chemistry, you will get to this place. So now we are jumping to give a glimpse of what goes behind a chemical reaction. So for you, because now that's your ethanol, it goes to your organic chemistry. Now for you to understand your organic chemistry reactions, there are a few things that you need to understand that I believe this is the right time for us to go and check them out. So I'm not going to give you the whole process of it, but the thinking behind. So what you need to know is your bonding, and also you're going to need to understand your acids and bases. Once you understand these two, you can be able to understand what goes through a chemical reaction, or what is called a reaction mechanism. So let's go and unpack bonding. So for your bonding, it's either there are electrons shared or there are electrons transferred. Now, if you talk of electrons shared, you'll be talking of covalent bonding. If we are talking of electrons transferred, you'll be talking of ionic bonding. Your ionic bonding is usually your metal and your non-metal where sodium would transfer an electron to your chlorine atom, and your covalent bonding would be your chlorine gas, where electrons are shared between the chlorine atoms, and then you get your covalent bonding. So this is where we'll be focusing. We'll be focusing on this side, and then we'll leave this for now. In your covalent bonding, because if you talk of chlorine gas, your electrons are shared equally, and sometimes you find that, okay, one electron comes from chlorine and the other electrons come from the other chlorine. Then you have two electrons shared equally in the molecule that we are talking about. And then sometimes you get, let's say you have your ammonia, which is NH3, and then an acid, which is H+. You would get something which is the ammonium ion. Now what happens here is, when you get your ammonium ion, if you check, this H+ doesn't have an electron, but when the electrons are shared now, it means both electrons here come from nitrogen. Then when electrons come from one atom, and therefore they, unlike this chlorine, one electron comes from chlorine, one other atom comes from the other chlorine. So they both come with electrons. But when one atom comes with nothing, and then another atom comes with both electrons that must be shared, that is what you call your dative covalent bond. And for your dative covalent bond, there is a show of an arrow showing that the electrons come from only nitrogen, but they are both shared by both these atoms, which is your nitrogen and hydrogen. It's dative covalent bond or coordination covalent bond. So let's keep that one in mind, and from there let's move to your acids and bases. So acids and bases, there are three concepts, which is your Arrhenius concept. Then this one, for an acid, it says that an acid, it produces hydronium ions when dissolved in water. And then your base, it produces hydroxide ions when dissolved in water. So an example of your acid would be HCl. Then when it is dissolved in water, it will give you your H plus your Cl minus. Because your product is H plus, sometimes this would be your H3O. H3O plus hydronium ion, it usually means the same thing. So that will be your acid because it has that H plus ion. And for your base in water, it would give you your sodium ion plus your hydroxide ion. Because it gives you the OH minus, it means this one is a base. Now, there is a shortcoming with this type of a concept because it only speaks of an acid or a base in an aqueous solution only when there is water. So there is another one from two guys who worked independently. It's called the Bronsted-Lowry. So the Bronsted and Lowry concept, it speaks of an acid as a proton donor, and then it speaks of a base as a proton acceptor. Now, an acid, let's say if you have your HCl plus your ammonia, this would give you something of this nature. which is your ammonium ion, NH4 plus the chloride ion. Now, if you look at this, the HCl is the acid. Now it donates the proton, which is the proton is H plus, and then it gives us NH4 plus. Then because ammonia, it accepts the H plus, now it is a base. So that is how you look at an acid and a base in terms of the Bronsted-Lowry theory. And then the last one would be your Lewis concept. Now this one, it speaks of an acid as an electron pair acceptor, then a base is an electron pair donor. Now what does this mean? If we look at HCl again and ammonia has lone pairs that haven't reacted to anything. So in this, ammonia would donate these electrons to hydrogen, and then this would break, and then it gives us your ammonium ion. Plus Cl minus. So ammonia donates a pair of electrons, and then once it donates a pair of electrons, it becomes a base, and then once it accepts a pair of electrons, it becomes an acid. Now this is mostly what you have to understand when it comes to reaction mechanisms, or what goes behind your reactions, especially your organic chemistry reactions. You have to know which one is an acid, which one is a base, or which one is an electron acceptor, which one is an electron donor. Now let's put it like this. If ammonia can donate electrons, it means it is electron rich. Then this one, if it can accept an electron, it means this one is electron poor. Now when your ammonia is electron rich, we can call it what is called your nucleophile. Then this one, you would call it your electrophile. Now what we want to understand is that your nucleophile will always, or most of the time, donate electrons to your electrophile. So this is the concept that we will use in order for us to understand how do we synthesize, let's say, ethanol from ethene. I think let's get to it, and then we can see how we apply all these things that we have spoken about. So this would be your reaction mechanism. Now this, we have an alkene, an acid in water to give us an alcohol. When you have a double bond, it means there is a concentration of electrons in that double bond, which means there in the double bond you have your nucleophile. And then when you have an acid, that means the hydrogen usually doesn't have electrons, so the hydrogen in the acid is what is called your electrophile. And from what we have already spoken about, it means your nucleophile will donate electrons to your electrophile, and then this will break, and then we will have something of this nature. CH2. Then let's put this hydrogen here. CH2 plus HSO4 minus. Okay, now when you understand your organic chemistry, you will know that carbon can bond up to 4 times. And when we look at this, you have 1, 2, 3, you have 3 bonds, which means now your carbon is short of a bond. Now that makes carbon your electrophile. And we also have, in the reaction, we also have water. Water has lone pairs. Because water has those lone pairs, it makes it a nucleophile. So water will donate your electrons to compensate for the electrophility of carbon. Then we will get something of this nature. But now this makes oxygen to become what is called your electrophile as well. Now this is a nucleophile because it is negatively charged. It will donate electrons to one of the hydrogens. Then this bond will break to form back those lone pairs, and then we have something like this. So then you have your H2SO4. H2SO4 was there, and then it is here again. This was your catalyst. A catalyst doesn't take part in the reaction as you would know it. And then now here you have synthesized your ethanol. Now these are the things that you will understand when you are an organic chemist and when you synthesize a number of drugs. So when you have ethanol, it means you are a step closer to synthesizing your hand sanitizer. So we stop there. That is, thank you from where I'm standing. Wait, before we go, what we spoke about, what I want to emphasize is that you always have to look for a nucleophile and an electrophile. Or maybe not always, or most of the times you look for an electrophile and a nucleophile. That is where most likely your reaction will occur. What we did there is an example of how you apply an electrophile and a nucleophile. So everything else, we were giving you the basis of almost all reactions. So that is what we were inspired to do by my fellow chemical analysts. Please keep doing that good work. Also, the ones that we did not mention that are at work and we are at home, we appreciate what you are doing for the country and also the world. This is for you. This is for us. This is for everyone. I hope we stay at home, and when we watch this in the future, we will be proud that there were people who stood in line so that we can be saved. Thank you very much. We'll see you when we go back to our usual sessions. This has been Basic Chem 101 with Sihle Bonani. My name is Sihle Bonani. Thank you very much. Booyaka!